Hello, DSI 2000. In this video, I'm going to cover data analysis in Python. I'm going to start off by giving some remarks on Python. Here are the main points I want you to get from this part of the presentation. Please pause and read before proceeding. Before we do anything, go to your Unit 8 folder in your DSI 2000 folder, and please make sure that the Unit 8 Data Analysis in Python student version IPython notebook is in there. So I'd like to give some remarks on Python. One of the things about Python is that it is generally considered the most popular programming language in data science. However, just because Python is the most popular, it does not mean that Python can do everything that R does. For the things that you've done in DSI 2000 so far, everything that is in the pandas package in Python is very comparable to what we've done in R using base R and dplyr. You will notice that when you enter industry that a lot of professionals will have very passionate opinions about whether R or Python is better. But in my honest opinion, when you compare pandas versus R, the functionality is pretty similar. And one thing I've observed is that someone who's usually very passionate about whether or not Python is better than R with respect to data manipulation tends to only know one of the two languages and not the other one. Another thing I've observed is that Python is usually preferred because most students who seem to be coming to data science tend to come with the computer science or software engineering background, whereas R seems to be mostly preferred from those who come from a stats background. From my professional experience, and you should know that I come from a stats background, I use R for most data manipulation stuff because I'm more used to it. Python, using the pandas package, is not that different, but it has its quirks, which I will teach you a little bit about in this video. Another thing is that if I want to run sophisticated stats, I use R. I actually don't trust Python to run my stats correctly because a lot of software engineers that develop stats packages in Python often aren't aware of the statistical interpretation and background of what it is they're doing, and they tend to focus solely on the code, which is a bit problematic. From a different perspective, if I need to run machine learning, especially machine learning in real-time production, I would use Python over R for that. Python is a lot better when you are trying to extend your uses of data for other tasks, such as machine learning in production, or if you say wanted to build an application of some sort which uses data. I would use Python. In short, from my perspective, R has its advantages, Python has its advantages, and they both have their disadvantages. My honest opinion is that those who tend to opine that R or Python are superior over the other are usually very misinformed, and they should really learn how both tools work because that's really what you're expected to do in industry. So to summarize, you're going to undoubtedly meet people who will claim that Python is in all cases superior to R. My advice to you when you meet such people is don't listen to them. You're going to notice that people are going to have very strong opinions about Python versus R, and especially from those who prefer Python. For the stuff I personally do, I can't trust Python for stats. These are not things that I have discussed in this class, but I encourage you to Google and do some searching on these concepts in case you're interested or ask me any questions. For example, I can't trust Python to do statistics. Their most popular machine learning package, scikit-learn, implements what's known as L2 regularization for logistic regression by default. It's unfortunate that they do this because statisticians have no reason to implement L2 regularization for logistic regression by default. Another thing too about scikit-learn, which is again the most popular machine learning package in Python, is that in the developer documentation for scikit-learn, the developers clearly have a fundamental misunderstanding of what logistic regression is. They call it, quote, a linear model for classification rather than regression. If you have studied logistic regression, it is actually just regression. The fact that one can treat it like a classification model is completely arbitrary and has nothing to do with the logistic regression modeling procedure. In my daily work, I use generalized linear mixed effects models. They're extremely limiting in Python. Python only offers the stats models package, which you can use to implement these, but only in a few specific cases. R is a lot more flexible about this than Python. Another argument that I tend to hear especially from those that tend to really think that Python is superior to R, is that they will often talk about how Python is better for use in machine learning and production. I do agree that Python is better for machine learning overall than R, but as I've mentioned in this class, you should not view machine learning as the one tool that you will use to solve all of your data problems. That is not a good way to view data. A lot of people think data science and data analysis must only involve machine learning. And I find that people who have that perspective often are quite misinformed of how data science works in practice if you're not in a tech company. While I do agree that Python is better for machine learning overall, you should not view machine learning as your one tool for approaching data problems, and that is definitely not the reason. Therefore, I would choose Python over R in all cases. Here's, I promise, the last slide I have talking about Python versus R. A lot of people will often argue that Python is objectively faster than R. I haven't seen this. I have not seen any evidence of this. And in fact, I've seen that more often studies seem to suggest that data.table in R is often faster than pandas in Python. Also, if you're looking for computational speed, you shouldn't be using R or Python. You should instead be using C, C++, or Java, neither of which I've had time to cover in this class. But if you really want fast speed, you should be using one of those three lower level programming languages as opposed to R or Python. One programming language that exists that's trying to bridge the gap between R and Python versus a lower level, more powerful language is Julia. I haven't looked into it, and I haven't really seen any signs of it taking off, but I do notice that there seems to be occasionally increased interest in it. So now let's just start going through the same stuff that we learned in R, except now in Python. So here's what I'm going to do. I'm going to go to my Anaconda prompt. And if you followed the installation instructions I gave you, you should be pointing to your DCI 2000 folder immediately. Let's ls here. And I'm going to cd to unit 8. Then let's do an ls here. And I'm going to do Jupyter Notebook. And I'm going to access the student version IPython notebook that I provided you. So, assuming that you followed all directions that I gave you for installing Python, the following should work without any errors. Go to Cell and run all. This will just run your entire Jupyter notebook from top to bottom. I've scrolled all the way to the top, and what I'm going to do is I'm just going to explain all of the code chunks inside this Jupyter notebook. So in R, we used the library function to load packages. In Python, what you do is use the import for the package. And in addition, in Python, you can add abbreviations to the package so that you don't have to type up the entire package when you're referring to it. So for example, import numpy as np, I can use np to refer to numpy every time I want to use numpy, which is really nice. These three packages I've loaded here are numpy, matplotlib, and pandas. NumPy is meant for scientific computing. If you need to do any sort of computing, you're probably going to use NumPy sometime. Matplotlib is what Python uses for data visualization. It's the analog to ggplot2 in R. And pandas is what is used for Python data analysis. So for the things that you've done in base R as well as dplyr, you're probably going to use pandas for it. Git will work exactly the same as it does with our R code. For example, if I go to my DCI 2000 folder, I can just go to git bash here on my unit 8 folder, and I can just git add on the unit 8 data analysis in Python, IPython notebook, and then I will just do a commit. and then a push. So it works the exact same way. So that's unit 2 when it came to loading packages in Python. Now let's start going through the equivalent of what we did in units 3 and 4, except now in Python. So the thing you need to know about Python is that Python is meant for a lot more general of a purpose than R is. The fundamental data structure in R is the data frame. If you have a data frame, you can use R to do whatever you want. And Python is not just meant for data analysis. Python can be used for all sorts of things, which is one reason why people prefer Python. You can do a lot more with it than you can with R. So rather than use base Python to do data analysis, you will have to use Python's packages to work with data in Python. For example, let's say I wanted to read in the simulated MN salaries CSV file from in the data files folder into Python. You will use the pandas package to do this, which recall we had given the abbreviation PD. So notice the following here. We are referring to the read underscore CSV function of the pandas package. In Python, you have to be explicit about where your functions come from, specifically what packages they come from. In addition, the assignment operator in Python is the equal sign as opposed to the arrow in R. So this is how you would read a CSV file in pandas using Python. Another thing too is that observe that we didn't need to talk about Python projects like we did with R projects. The thing about Python scripts is that generally by default, you assume the working directory is wherever the Python code is located. So for example, here, we're in the unit 8 folder, so I have to go back one folder using the 2 dots to the data files folder, and then open the simulated mnsalaries.csv file. So this has created a data frame called df. Notice how data frame is one word in Python, and we can view the data frame like so. Just type df and run that code. Let's talk about indexing. Remember that in R, how you indexed was using one indexing with brackets and 2 numbers separated by a comma. For example, df11 refers to the entry in the first row and the first column of the data frame df. Python is not a one indexing language. R is considered to be a one indexing language because 1 refers to the first index of a data frame or a vector in R. In Python, 0 is used as the first index of a vector or a data frame. So in this situation, df00 would refer to the first row and first column in Python, as you see right here, this 99994. In addition, you have to specify that you're referring to a certain property of the data frame called iloc, or the integer location. So for example, this situation, we're referring to the integer location corresponding to the first row and the first column of the data frame df. And remembering again that Python is a 0 indexing language, 01 would refer to the first row and second column. One of the things that you'll often run into if you're translating between R and Python is you have to be careful to make sure that you convert your indexes appropriately between R and Python. Make sure in R that you're aware that 1 denotes the first index, and in Python, 0 denotes the first index. In R, one of the things I discussed was what happens when you omit a certain index. If you omit a column or a row index, it will show the entirety of columns or rows respectively, depending on which one you decide you want to omit. In Python, instead of omission, what you do is you use colons instead. So for example, df.iloc 0, colon would be the same thing in R, except this colon would just be a blank. And because I'm using a colon on the column index, I'm referring to the first row and all columns. So df.iloc 0, colon refers to the entire first row of df, i.e. the first row and all columns. df.iloc : 0 refers to all rows and the first column. In R, another thing I discussed was that you use negative indices to indicate removal. For example, df -1 in the row index would refer to removing the first row of the data frame df. In Python, rather than viewing it as removal, what you do it is you view it as showing everything from the second row onward. Remember that Python is a zero indexing language, so the second row is indicated using the index 1. So to show everything from the second row onward, what you do is you use 1 colon, as you see here, with no commas in it. So this shows everything from the second row onward. Another thing we discussed in R was this $sign construction. If you wanted to refer to the year column of df, you could choose between either one of these two options. In Python, you can use either df with year in brackets or df.loc with the colon showing all rows and then the corresponding column name, as you see here. This is showing the year column of df in two different ways. In R, I had discussed head df, which prints out the first 6 rows of df. In Python, we use df.head, which instead of printing out the first 6 rows, it prints out the first 5 rows, as you see here. Next, in R, we had discussed for loops. This is a for loop for I equals 1 to 5 inclusive, printing the corresponding value of I. Python is a zero indexing language, so it's customary instead of using 1 through 5, you use 0 through 4. And how you would do that is you would use the range function. So in this situation, we would use for I in range 0 to 5. Note that this is 0 to 5, but not including 5. So it starts at the beginning and goes all the way to 1 prior to the last one. So this prints everything from 0 through 4. Notice that Python's loop does not include curly braces like ours does. In Python, how you indicate that you're doing a loop is you use a colon to indicate the end of your condition for I, and then you indent lines of code as appropriate for your loop. In R, we had this if statement where we said give x a value of 1, and if x is greater than or equal to 3, print yes, otherwise print no. The equivalent of this in Python would be as follows right here. Observe again that we're using colons instead of curly braces to show what happens under each condition. Lastly, we had discussed creating functions in R. How you did this in R was as follows for this add2 function. So when you run add2/4, it returns 6. In Python, instead of function, what you do is use def to define a function. And otherwise, the syntax is very similar. And of course, instead of using curly braces, you would use a colon. Now let's talk more about the things that we discussed in R when it came to vectors. The data frame in R has a two-dimensional analog in Python known also as the data frame except one word, which I had just discussed. The vector in R has a one-dimensional analog in Python known as the series. Recall that C123 in R is a vector consisting of the numbers 1, 2, and 3. In pandas, to execute a series, which is the analog of a vector, you would use this code right here for the vector 1, 2, 3. And of course, you can index it using the iloc, just like we did with data frames. For example, x.iloc0 will show the first component of the vector x, which is the 1 right here. I will not be covering data string manipulation in Python, but what you've learned in R easily extends to Python. For example, recall date manipulation. What you do in pandas is use the toDateTime function, and you put in your string and you specify a conversion specifier for your date, just like we did in R using the as.date function. You can also look at this website right here to find examples on regex and other basic string manipulation in Python. Now let's start talking about data manipulation in Python. So this is just Unit 5, except now in Python. If you want to select a column, I've already discussed this, you just use df with the column name in brackets. If you want multiple column names, you will need 2 brackets, and in the middlemost pair of brackets, you will have to indicate your column names separated by commas. So this is, for example, selecting the sex and race columns of df. Filtering works a lot like it does in base R. For example, here we are showing all rows of df for which the year is equal to 2008, as you see here. Observe that we have no comma here, and I do wrap parentheses around the condition. The reason why is because when you start using multiple conditions, if you don't wrap parentheses around the conditions in Python, your filtering will not work. Also, just like with base R, pandas will show NAs or NANs by default as does base R unless you explicitly remove them. So for example, if I don't want NAs in the sex column, I have to manually specify it right here using dfsex.notNA. And observe here that all of my conditions are wrapped around parentheses. To view the unique values in a column, what you do is you use the drop duplicates function. You could also use this construction using .loc as well. These are the unique values in the sex column, and these are the unique values in the race column. Let's talk about filtering for unduplicated values. What you do is you would select the race and sex columns if you're interested in all unique pairs of race and sex, and then you would just use drop duplicates on the data frame. So this here is, for example, showing all unique pairs of race and sex in the data. For renaming your columns, what you do is use your data frame and you put .rename next to it. And then you would specify in the rename function a columns argument with curly braces, the old name on the left and the new name on the right. This, for example, here changes ID to new ID. Let's talk about sorting of columns. In Python, what you do is you would use df.sortValues, specify the columns you want to sort by, and whether you want them ascending or descending. So this, for example, is sorting by year and salary in descending order. Observe that the Python logical true-false is not all caps like it is in R. Only the first letter is capped in true or false inside Python. Let's talk about calculated fields. So in base R, we had created a new field called salary Canadian, which was 1.33 times df of salary. The equivalent code for this in Python would be as follows right here. And you can see salary Canadian has been added. I had also given a tax rate example through which, depending on the salary, you would return a certain tax rate. You should, in Python, define a function to return the appropriate tax rate, as you see right here. elif, just so you know, just means else if. And then what you would do is you would just do .map on the corresponding column to create the tax rate column, as we see right here. For talking about aggregation, it's very similar to dplyr. You do a group by and then you do a summarize, or in this case, an aggregation. So for example, here we're doing average salary by year and sex. So we're grouping by year and sex, just like we did in dplyr. And then we're aggregating, returning the mean of salary, as you see right here. Let's talk about joins in Python. So we're going to read in the CSV file consisting of cities, like you see right here. To do an inner join, it's just like in R. You would use the merge function, and you would have to first specify what is going to be the left table, which is df right here. And then in the first argument of merge, you would specify the right table. And then you would specify the columns that you want to join on both the left table and the right table. So this is going to be joining by the ID columns of both tables. If you don't specify anything else, just like with the merge function in R, Python will assume that you're doing an inner join. To do a left join, it's the same thing except you add the argument how, and you can set that equal to left, right, or outer, outer being a full join. Quick little word of caution that I don't really have that much time to get into, but I would encourage you to look into this if you plan on diving more into Python and data analysis. I hope you've seen so far that Python is very similar to R when it comes to data manipulation. But let's take the following example to show why you need to learn Python in a little more depth to use it in a professional environment. For example, let's say that the IDs in DF should actually be double what they are. You could try to correct this one column as follows. Make DF2 just the ID column of DF, and then make the ID column of DF2 just the old ID value times 2, correcting the IDs to be double what they were. But then what happens is you get this setting with copy warning. And this is one thing that R does not make you think about that Python will make you think about. The reason why you get a warning is because Python preserves the original data frame reference as you're manipulating data frames. So what do I mean by this? When you are creating this df2 to refer to the ID column of df, and then you're doubling it, what's happening here is that when I'm saying that I'm manipulating the ID column of df2, it actually thinks that I'm trying to manipulate the ID column of df, which is obviously what I don't intend on doing. I only want to change the ID column of df2, but because Python preserves references, it thinks that I'm referring to the ID column of df and not of df2. So Python's giving me a warning because it thinks that I'm trying to manipulate two things at once, because this df2 is referring to two different ID columns from two different data frames. R does not make you think about this, but Python does. Python will preserve data frame references as you're manipulating them. R hides the fact that when you do something like this, it doesn't actually preserve the original data frame reference. What it does is, in the background, R actually makes a copy of the new data frame with the changes implemented, and then it changes the df reference to the new object. So to get around this problem, what you do is you make df2 a copy of df, so that when you manipulate the df2 column ID, it doesn't give you an error because it knows that you're not trying to manipulate the original df, and therefore it doesn't give you a warning. And now all ID values have been doubled. If you want to learn more about this, you need to learn some object-oriented programming, which I don't have time to cover in this class, but I just hope that this illustrates to you the need to understand object-oriented programming in data science. Lastly, I'm going to talk about data visualization. So now we're just extending ggplot2 to matplotlib in Python. I'm going to load the iris dataset via scikit-learn, as you see right here, just like we did in R. To get a plot of the sepal length on the x-axis and the sepal width on the y-axis, you can run this code right here. If you're interested in understanding the code in more depth, I have commented each line of code so that you understand what it is doing. And then next, to color by species, you would use this code right here to get different colors for all three species in this data set. And that's really all I have for you. Please let me know if you have any questions.